Okay, hello, welcome back. In the previous lecture, I introduced the definition of covariance and the correlation coefficient. The motivation is to describe the relationship between two random variables. In particular, we are looking at their linear relationship, and even more particularly, we are interested in the direction and the strength of their relationship. And so we defined a numerical measure, covariance, but it could capture the direction, the sign of the relationship, but not the strength. On the other hand, the correlation coefficient, which is a kind of standardized covariance, could capture the strength as well as the direction. So when you interpret, you have to be careful whether you can compare the magnitude between different pairs of random variables or not. And today, what we're going to do is to consider another example. It's literally pretty similar to what we did in the previous lecture, but the major difference is like this. In chapter 3 and chapter 4, for example, when we learned how to calculate the mean, there were two different cases. One is when you have the raw data, and the other is when you have a probability distribution table. So when you have the raw data with many observations, then then we learned to calculate. We can calculate the mean by adding all the numbers and then divide them by the number of observations. However, when you have probability distribution table, then you learned that you have to utilize the probability as the weight. So you have to calculate probability weighted outcome and then sum them. If you remember what we did, it's similar in calculating the variance, the standard deviation, and also when you calculate the median, we have to distinguish whether the data are raw data or some summary like probability distribution table. And in this chapter, we are doing something similar, and in the last lecture, we learned how to calculate the covariance and the correlation coefficient when you have the raw data, like when you have an Excel file. If you have an Excel file with a lot of entries, then I showed you can just use formula on Excel. However, we are going to consider what we did not consider in the last lecture is that if what happened, how to calculate the covariance or the correlation coefficient if you have probability information. So let's think about this example. Our main theme is financial diversification. I made this example based on financial economic, the very basic theory in financial economics. And suppose that there are two financial assets, A and B. You can think it as like mutual funds or ETFs or like firms, whatever, two financial assets, and their returns depend on the economic state. So for example, say economic state is the market situation, can be in three different situations: boom, normal, or recession. So it can be good or normal or bad, and depending on the state, each asset's return is determined. So asset A is a pro-cyclical and risky asset. It is called pro-cyclical because its return increases when the market state is in boom. So if everything else goes up, then A goes up together. It moves together with the market. It goes down when in recession. So in that sense, it's pro-cyclical. And it's risky. That means the best output and the minimum output have huge difference. On the other hand, asset B is counter-cyclical and less risky, kind of safer asset. So I said counter-cyclical because B is doing better in recession. It's a very strange asset, just imaginary asset. So usually most of the financial assets do better in boom. Of course, follow the trend. But if there exists an asset like this, it will be really, really rare and really scarce. So it will be very valuable. So anyhow, it does better in recession and worse in boom. So it's going the other way somehow. And also it's less risky because the difference is smaller. So around it's 6 to 14, but A relative to A, it's the variation is smaller, 6 to 14, but A ranges from 4 to 20. So the range of A is much larger. And their probabilities depend on the probability of state, the market state. Simply, I will assume 25%, 50%, and 25% for the three states. In this case, we are interested in the relationship between those two assets. If they are how they are correlated, how much they move together, or if they are moving the other way, if we can utilize them to diversify our risk, hedge our risk. So then, first, let's think about how to calculate their correlation coefficient or covariance. The first thing we have to do is to find the mean, right? So, and it's easy, so I assume you can do it. So mean, when you calculate the mean of A and B, you have to utilize these three probabilities. Say, for example, for A, 20 per 20, return 20, say, it means like returns of $20 happens with 25%, $8 with 50%, $4, 25%. If you don't like the numbers, you can say, the company A has a net profit of $20 million last year, for example, something like that. Probably using those probability and the outcome, you know how to calculate their mean. So then you will obtain the same mean for both assets. So two assets are very different, but in terms of their mean, they are the same. And the expected return is the same. And the reason why we use this, we calculated the mean is because we need to calculate the deviation to calculate the covariance. So deviation of A is simply its return minus mean. So when its return is 20, that means 10 above the mean, and A means 2 below the mean, and 4 is 6 below the mean. And also deviation for B is minus 4, 0 plus 4 relative to the mean. And using those two deviations, you multiply them, which is exactly same as before, but like on top of them, we also multiply the probability. So when you multiply the cross product, after multiplying the cross product, then you would be adding them up, but before adding them up, you have to multiply the probability in the last step. Before adding three cross products, we have to utilize the probability weights. So multiply 0.25 times cross product, 0.5 cross product, 0.25 cross product, and then you will get minus 10, 0, minus 6. These three guys are probability weighted cross multiplication of deviations, right? Cross product of deviations from two random variables. It's confusing. There are two random variables, and there are many outcomes, and there is probability, And what we are doing is we are calculating deviation, deviation and multiply. Deviation, deviation, multiply. And if you did not have the probability from the earlier lecture, the previous lecture, if you had raw data, we did just calculated the deviation from x, deviation from y, and then multiply and do that for all entries, all observations, and sum them, average them. That is how we calculated the covariance. But now, because you have probability, when you take the average of the cross product of deviations, you have to utilize the probability. So in this step, you multiply the probability to the deviations. And then covariance is minus 16. You get minus 16. And I want you to try it by yourself. It's a little bit complicated, but if you have enough practice in chapter 3 and 4, this should be similar. You may feel it's pretty similar to what you have done in the earlier chapters. So then what we can tell from here is that so first, like two assets, these assets A and B have the same expected returns. And so therefore, when their expected returns are the same, like usually investors prefer a safer asset, which is like asset B, right? But so that's true when you have to choose only one of them. But now we are going to consider something beyond it. So now why don't you just invest in both of them, right? Suppose that you have suppose that company A and company B, there are two stocks, and then you may invest 50% of your asset on one and the other 50% on the other company, right? That is also possible. And then you can expect that the negative covariance will help to diversify the risk because the returns have negative relationship, which is shown by the negative covariance. Then when it's not doing well, then the other company can compensate, and vice versa. They complement each other, so they are complementary to each other. So overall, your risk will be reduced, which is very intuitive, and many of you already have this kind of basic intuition, I believe. So what we are going to do is we are going to think about an experiment like this. We will consider a new portfolio investing on both A and B. So simply I will write X as A plus B. So you buy one stock from A and another stock from B. So and the dividend from A can be 20, 8, or 4, and dividend from B can be 6, 10, or 14. So your total dividend is 26, 18, and 18, 26, 18, and 18 in your portfolio, depending on from your portfolio, depending on the state of the market. So if it is in boom, then your portfolio will return $26. And recession or normal, 18 is the dividend, right? You understand? So in this setup, what I'm going to ask you here is, we will study the risk of this portfolio when you invest on two companies at the same time. And usually the risk is measured by variance or standard deviation, usually standard deviation, but we are going to use variance for a while. And based on the same probability distribution, if you calculate the variance, you can find that variance of A is 36 and variance of B is 8. So B, as you can see, B is much safer than A. Smaller variance is better for investors. So considering these variances, if you think about these numbers, then what do you expect from the portfolio? So what would be the variance of the portfolio X given these result? You may do the algebra, but you may use your intuition and see, just guess what would be the answer, and then try to calculate, do the algebra to calculate the variance of X. I will continue in the next video. See you later.